All right, so today's stuff out of 8.4 isn't really anything new. We're just going to combine everything we've been working on all week. So when we say that you're supposed to solve a triangle, all that means is that you're going to find all of the missing angles and all of the missing sides. So whatever they didn't give you, you're going to have to go ahead and find all of those things. And so on your notes for today, what you're going to notice is that we've tried to remind you of kind of the major points of things that we know so far, right? So if we're talking about angles, interior angles in a triangle, those are always going to add up to 180. I think most of us feel pretty confident about that at this point, right? We've got linear pairs. Linear pairs, again, two angles that form a line, that's also going to be a 180. So remember what they're showing you on this picture, okay? This angle to the outside and this guy on the inside, right, angle C, those are going to form a linear pair. An exterior angle has to do that. Okay, it can't be vertical, it has to be a linear pair. And then exterior angles are equal to the sum of the two that it doesn't touch. So again, we've done a lot, we did some review with that on that formative. Okay, and that's kind of what we know about angles. We also have a little bit, again, if you need to remind yourself, remember that in an isosceles triangle, okay, that if I have the two sides that are the same, I also know that the base angles are the same. Again, that got reviewed on your formative as well, but that was that isosceles base angle theorem. So just a couple things to remind you on triangles in terms of their angles. And then recall that on their sides, we've got a lot of different ways to solve at this point. Okay, so side lengths, you could do it by definition, right? If they tell you that you have an equilateral triangle, you know all your sides are the same. If they tell you have isosceles, then you could set two of them equal to each other. This is going to be very specific to right triangles. Okay, so it has to be a right angle. If you know two sides, you could use a Pythagorean theorem. Okay, now two sides, you could also use trigonometry, but you can use a Pythagorean theorem anytime you have two sides. If you happen to have the special right triangle, so if you have the 45-45-90 or the 30-60-90, if you have one of those and you recognize it, you can absolutely use those relationships. Okay, it might just save you some work. Or if you have a side and an angle, you have to use trig. We don't have another way to solve that. And so that's going to be the idea of SOHCAHTOA. So as we move forward today and we're asking you to solve a triangle, it's going to be your choice sometimes as to how you do that. And there might be more than one way to do it. Okay, so as we look at this first example set, okay, again, we're going to solve it for all of our missing measurements, and we're allowed to round our answers to the 10th place. Okay, so no matter how you solve, you're absolutely allowed to round. So here's the angle that they gave me, 19. And right away, I can go ahead and find angle D. If triangles have to add to 180, then I can absolutely go ahead and find that. Okay, so if we punch that again, so we'd have 180, get rid of that 90, and then we're also going to get rid of 19. So angle D is going to be 71. Okay, we're going to be careful to put that degree symbol after it just to make sure. Again, in our class, we do degrees, but angles can be measured in different ways, and so we want to get into that good habit. Now, as I'm looking at my sides, I'm noticing I only have one side length. If you only have one, and you don't have a special right triangle, you have to use trig. It's our only way to do it. So again, just to remind ourselves, SOHCAHTOA. All right, so here's the angle they gave me. I'm noticing that here's my right angle, which means across from my right angle, this is my hypotenuse. From 19, if I trace this side, right, I'm noticing that it does not touch the 19. This side is opposite, and this side is going to be adjacent. Now, I need all of the sides, so it's your choice as to which one you want to start with. So, for example, if I want to go ahead and find the adjacent side, opposite and adjacent would be a tangent function. Okay, so tangent of my angle, 19, would be equal to opposite over adjacent. Okay, so we'll multiply both sides by that A. So A multiplied by the tangent of 19 is equal to 21, and then we'll divide by the tangent function. And so that side, so again on our calculator, 21 divided by tangent of 19, it's going to come out to 60 point, oh, see now this is going to be one where it's going to round up, so that'll be a 61.0. Now remember, this is a side, so I'm not putting degrees after it. Okay, that one's going to be a side. So A, here we go, 61.0. Now, you have two sides, so you could do Pythagorean theorem to find your hypotenuse, or you could do another trig function. I don't really have a preference. If you're going to do the trig function, I'm going to use the side that they gave me. Just in case I made a mistake over here, I wouldn't use an incorrect answer to find the next one, right? So it just gives me an opportunity to not miss both. Okay, but you could also do Pythagorean theorem. It's absolutely up to you. I'm going to go ahead and do trig. So here's opposite and hypotenuse. That's going to be a sine function. Okay, so sine of 19 equal to opposite over hypotenuse. And then it's going to be the same process as below. So we multiply both sides by h. So h multiplied by the sine of 19 is equal to 21. And then we go ahead and divide. All right, and so 21 divided by sine of 19. All right, so my hypotenuse should come out to 64.5. So a couple things you want to check for, right? Is your hypotenuse the longest side of your triangle? And it does appear to be, right? I've got a 21, a 61, and a 64.5. So that absolutely appears to be true. We double checked our angles. That's going to come out to 180. Now again, if I want to check my sides, right, a squared plus b squared should be equal to c squared. So if I take 21 squared, sorry, you can't see that. So if I take 21 squared plus, I found 61 squared, okay, so 4162. If I take a square root of that function, right, comes out to 64.5, which is roughly, now again, that's rounded, but we rounded in our work. That's roughly what I got for my hypotenuse. So we're feeling pretty good about those answers. Okay, if I look at my second one, this was kind of, I have it work all over the place. So as we look at part B, right, I'm noticing right away I've got two sides. So if I already have two sides, I can go ahead and use Pythagorean theorem. Okay, so across from, here's my right angle, across from here, this is hypotenuse, which means these two sides are my legs. Okay, so if I call this one an x, all right, so 8 squared plus x squared should be equal to 12 squared. Right, so x squared is equal to 144, and again, we'll subtract that to the other side, so minus 64. Okay, 144 minus 64, it's going to come out to an 80. Now again, I'm allowed to round, okay, so I don't have to, even though we could, right, we could absolutely break that down into the radical. It said tenths place, so we're okay to just go ahead and take a square root. All right, so x is going to come out to about 8.9. Again, that's a side, right, that's our side. So there's one of them. Now we've got to find the other angles. This is what you were practicing yesterday. Okay, so if I want, let's suppose I'll start up here because it's a little easier to see. If I want angle A, okay, again, you can use whatever sides you have. I like to use the ones that they gave me just in case I made a mistake, right? I'm not going to use that incorrect value for the rest of it because then I just miss everything else. So from A, right, we know this is the hypotenuse and this side touches. Okay, so I'm going to use that as adjacent. So my trig function that involves adjacent and hypotenuse, that's going to be a cosine. Right, so cosine of my angle is equal to adjacent over hypotenuse. This is what you practiced yesterday. I want to get the angle by itself, so I need to undo cosine. Right, that's what we had that little -1 for. So on your calculator, okay, angle A is going to be equal to the cosine inverse, and then we type the fraction just like we see it. Okay, so on our calculator, we use the second key and the cosine function, right? You know you've got the angle because you're going to get that little -1 there. And then I type the fraction just like we had it. And so angle A should come out to 48. Again, we'll go to the tenths. So 48.2, and that's a degree, right? And that's an angle. Now, to find angle B, I can either do a trig function again, or all your angles have to add up to 180, and so we could just subtract, right? So angle B would have to be equal to 180 minus 90 minus 48.2. All right, so 180 minus 90, and it is also fine. Some of you might have discovered at this point, like you can just start with the 90, right? You could have just done 90 minus the 48.2. That's fine too. All right, so it should be a 41.8 degrees. And again, if you're not sure, you can always do the trig and double check your answer. Okay, so if I did that, right, this should be the sine, right? So the sine of this should be equal to 8 over 12. So if I check that real quick, sine of 41.8, okay, and then that's about 0.6 or so. If I take 8 divided by 12, right, again, 0.6 or so. So they come out to about the same thing. So again, you can always use the trig to check your answers to make sure that you've got them correct.